Here we have lesson 4.6, where we're going to talk about first solving by finding the square root. So in order to solve using the square root, we have to get the squared term by itself. So we're going to move everything away from it. First being we need to move the 10 to the other side by subtracting it. We've got 4x squared equals 36. We'll then divide by 4, and we're left with x squared equals 9. At this point, we have to get rid of the squared term. So at this point, to get rid of the squaring, we'll square root. And in this case, we get x equals positive and negative 3. Remember, when you square root a number, the square root is telling you the number times itself that gave you the original value. So 3 times 3 is 9, but so is negative 3 times negative 3. All right, for question B, same idea. We're going to try to isolate the x squared, so we're going to add 5 to the other side. We've got 3x squared equals 30. Divide by 3. X squared equals, in this case, 10. Now we want to square root both sides. And so in this case, we're going to get x equals, well, 10 isn't a perfect square, so we're just going to say plus or minus the square root of 10. So go ahead and try the two problems at the bottom, A and B, and pause the video, and when you're ready to see the answers, unpause it, and we'll go from there. So here we're going to talk about solving perfect square trinomials. And so perfect square trinomials are, in this case, when we factor it, we're going to see that the trinomial factors into the square of a binomial, or it's going to factor into two binomials that are identical. And so since we have a perfect square trinomial here set equal to a constant value, we'll go ahead and factor this trinomial. So x squared plus 4x plus 4 equals 25. So we factor this half here, it's going to be x plus 2 squared equals 25. At this point, we're going to go ahead and square root both sides. The square root will cancel the squaring here. We get x plus 2 equals, in this case, plus or minus 5. So here we have to account for both of these options. So we're going to have x plus 2 equals 5 and x plus 2 equals negative 5. And then we just want to solve. So we'll subtract 2, and we get x equals 3. Subtract 2, and we get x equals negative 7. So our answers are x equals 3 and x equals negative 7, or negative 7. So now try the problem right below it, pause the video, and when we're ready to see your answer, unpause the video. Not every occurrence we come across is going to be a perfect square trinomial, so sometimes we have to create them by what is called completing the square. And so here we see you can form a perfect square trinomial from x squared plus bx by adding b divided by 2 squared to the equation. And so that'll help us create a perfect square trinomial. So in this case, we're looking to see what value completes this square. So we're saying x squared minus 10x plus what is going to create a perfect square trinomial. To calculate this is where we're going to take the b squared, or b divided by 2 squared. So keep in mind that this is our b value. So negative 10 divided by 2 squared. And in this case, that would be negative 5 squared, which is just 25. So this is the value that's going to complete our square. So the answer is 25. And so now we can take this and rewrite this as the factored form, which would be x minus 5 squared. So now here we have the steps for solving an equation by completing the square. There are 5 steps. The goal is to rewrite the equation in the form x squared plus bx equals c. Then you're going to calculate that same value that we just saw to complete the square, and we're going to add it to both sides of the equation. We'll then factor the trinomial, find the square roots, and solve for x. So this is something to keep in mind as you go forward. So here it says What is the solution of 3x squared minus 12x plus 6 equals 0? We should notice right away that this is not a perfect square trinomial. So we can go ahead and start by moving the 6 over because we're going to have to complete the square. We get 3x squared minus 12x equals negative 6. But before we get too far, we should recognize that each of these terms is divisible by 3. So let's go ahead and reduce this problem by dividing everything by 3. Makes it a little easier for us. So x squared minus 4x equals negative 2. So at this point, we now want to figure out what has to get added in here to complete the square. So in this case, we'll have b divided by 2 squared, which in this case would be negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we're going to add that to both sides. So we're going to get x squared minus 4x plus 4 equals negative 2 plus 4. We'll go ahead and simplify this down. This is going to be 2. Here, we're going to go ahead and factor this perfect square trinomial into x minus 2 squared. To get rid of the squaring, we would square root both sides. And we're going to get x minus 2 equals plus or minus the square root of 2. And so at this point, we're going to have two answers, so we can kind of account for it here. But it's going to be x minus 2 equals the positive square root of 2. And then we've got x minus 2 equals negative square root of 2. In both cases, we're adding 2 over. So one answer is going to be x equals 2 plus the square root of 2. And the other option, we're going to add 2 over again anyway. So it's going to be x equals 2 minus the square root of 2. Here, I want you to give this a shot. If you want, you can try it on your own by pausing the video, or you can walk through the steps with me. So for this problem, we notice it's not a perfect square trinomial, but let's bring this x over by subtracting it. So that's going to give us 2x squared minus 2x plus 3 equals 9. We'll move the 3 over by subtracting it. So 2x squared minus 2x equals 6. Notice here everything is divisible by 2, so we'll go ahead and reduce it. So we've got x squared minus x equals 3. We need to figure out what we have to add to both sides, so we're going to have b divided by 2 squared. In this case, our b value is 1, so that's 1 divided by 2 squared, or negative 1. In this case, it's going to equal 1/4, so we're adding 1/4 to both sides of this. So we've got x squared minus x plus 1/4 equals 3 1/4. We can factor this side. It's going to become x minus 1/2 squared equals 3 1/4. Before I square root this, I'm going to go ahead and change this fraction into a improper fraction. So instead of 3 1/4, I'm going to get 13 over 4. So then I square root this. And in this case, I'm going to get x minus 1/2 equals plus or minus the square root of 13, because that's not a perfect square, but I can square root the 4, so it would be 2. And then I know that I have to, in this count, add the 1/2 to both sides. So it's going to be x equals, in this case, we'll have 1/2 plus or minus the square root of 13 over 2. You can write them separately, but it's just as easy to write them all at once. But in this case, this is the route I took. All right, and from there, we also know that we can use completing this square to write quadratics in vertex form. To write a quadratic in vertex form, you're going to use the very similar steps of completing the square. We're going to find that same value where we take b divided by 2 squared. And we're going to add this to different portions of this equation. But first, let's just calculate what this is. So it's going to be 4 over 2 squared. That's 2 squared, so this is 4. So we get 4, and so what we're going to do is we're going to take y equals x squared plus 4x plus that new value minus 6, and then we're going to take away that value again, so that way it really doesn't change the equation. It's just allowing us to manipulate how the form looks. So we're going to put the 4 here, and we're going to put the 4 here. So by adding a 4 and subtracting a 4, we're basically negating what we're doing, but it's allowing us to rewrite this in vertex form. So we'll factor this trinomial here, so we'll get x plus 2 squared. And then here we'll go ahead and combine these. This is minus 10. And so this is our vertex form for our quadratic. And remember, vertex form is y equals a times x minus h plus k, where h and k represent your vertex. So for this problem, our vertex is the point -2, -10. And our y-intercept for this particular problem was up here, so the y-intercept would just equal -6. Or in this case, you could write as the ordered pair 0, -6.